Ever wondered if there's more than one universe out there? Welcome to the concept of the multiverse. Now, before we dive in, let's get something straight. When we talk about the multiverse, we're not talking about alternate dimensions where you're a rock star or a supervillain. We're talking about a theory, a scientific idea that there might be other universes beyond our own. The multiverse theory suggests that our universe, the one we see when we look at the stars at night, might just be one of an infinite number of universes. Some might call it the ultimate reality show, but without any cameras, of course. Scientifically, there are 4 different types of multiverses proposed. First off, we have the Level 1 multiverse. This type is all about space, or more specifically, how much of it we can see. According to this theory, our observable universe is just a tiny bubble in an infinite cosmic ocean. Beyond our sight, there could be other bubble universes similar to ours. Next, we have the Level 2 multiverse. This type gets a bit weirder. Here, other universes could have different physical laws. Maybe gravity doesn't exist, or perhaps time flows backward. It's all a bit Alice in Wonderland, isn't it? Then there's the Level 3 multiverse. This one comes from the world of quantum mechanics, where particles can be in multiple places at once. This theory suggests that for every decision made, or every random quantum event, a new universe splits off. Finally, we have the Level 4 multiverse. This is the most abstract of them all, suggesting that any mathematical structure that could exist does exist as its own separate universe. So, are we living in a multiverse? The answer is still up in the air, but isn't it a fascinating thought? We might be just a tiny part of an infinite cosmic landscape, forever exploring our own little bubble, while countless others exist beyond our reach. It's a humbling, mind-boggling concept, and who knows? Maybe one day we'll find a way to peek beyond our universe and see what's out there. Black holes, the universe's ultimate trash compactors, or gateways to other dimensions. Let's unravel the mystery. Black holes, in essence, are celestial objects with gravitational pulls so strong, not even light can escape their clutches. Now, isn't that something to marvel at? Born out of the explosive deaths of massive stars, an event we fondly call supernovas, they are the universe's ultimate enigma. So what are the types of black holes, you ask? Well, they come in 3 main sizes. Small, and by small, I mean about the size of an atom, but with the mass of a mountain. These are called primordial black holes. Medium, or stellar, which are approximately 20 times more massive than our sun, and large, or supermassive, which are millions or even billions of times more massive than our sun, often found at the center of galaxies, including our very own Milky Way. As for their role in the universe, it's a bit like a cosmic recycling program. When a black hole feeds, devouring matter and energy, it also emits intense radiation. This radiation can trigger the birth of new stars and galaxies. So, in a way, black holes are playing a crucial role in the cosmic circle of life. In recent years, black holes have also been put forward as possible gateways to other dimensions or universes. This idea comes from the concept of wormholes, hypothetical shortcuts through the fabric of space-time. If a black hole could indeed be one end of a wormhole, it might just be our ticket to a whole new universe. But before you get your spacesuit ready, remember, this is purely theoretical. We've yet to find any concrete evidence of wormholes, let alone travel through one. So for now, we'll have to be content with exploring black holes from a safe distance. Black holes, the most mysterious objects in the universe, continue to puzzle and fascinate us, don't they? So let's keep exploring, keep asking questions, and who knows, we might just stumble upon some answers that will change our understanding of the universe forever. Ever wondered if there's another you out there in a parallel universe? Imagine if, at every moment of decision, the universe split into multiple realities, each one playing out a different outcome. This is the premise behind the concept of parallel universes, a mind-bending idea that has intrigued scientists, philosophers, and sci-fi fans alike. The concept of parallel universes, also known as the multiverse theory, stems from quantum mechanics. In the famous double-slit experiment, particles behave both as particles and waves, seemingly existing in multiple states until observed. This led to the many worlds interpretation, which proposes that for each possible state, there's a separate universe where that outcome is a reality. In these parallel universes, everything would be strikingly similar to our own, with one or more differences. Maybe in one universe, dinosaurs never went extinct. In another, perhaps you became a rock star instead of an accountant. The possibilities are, quite literally, endless. But is there any scientific basis for the existence of these parallel universes? Well, the answer isn't clear-cut. While the many worlds interpretation is a valid interpretation of quantum mechanics, it's not the only one. Other interpretations don't require the existence of parallel universes. And though the idea is fascinating, it's also currently untestable. Without a way to observe or interact with these supposed universes, we have no concrete proof they exist. Yet, the idea of parallel universes isn't entirely dismissed by the scientific community. Some cosmologists suggest that during the rapid inflation of the universe after the Big Bang, bubbles of space-time might have formed, each one potentially a separate universe with different physical laws. In the end, the existence of parallel universes lies at the intersection of science and philosophy, a tantalizing possibility that challenges our understanding of reality. So, next time you're faced with a tough decision, remember, somewhere in the multiverse, another version of you might be making a different choice. Parallel universes may sound like science fiction, but who knows what secrets the universe holds? Ready to take a thrilling journey to the edge of a black hole? Strap yourself in, because it's going to be a wild ride. Black holes are the universe's greatest mysteries, fascinating and terrifying in equal measure. They're the ultimate manifestation of gravity's might, warping space and time to a point of no return. Imagine you're aboard a spaceship heading towards this cosmic oddity. As we approach, the black hole's gravitational pull strengthens. This is the gravitational gradient, and it's about to give us the ride of our lives. We're now at the event horizon, the boundary marking the point of no return. But don't panic just yet. Contrary to popular belief, crossing this boundary doesn't mean instant spaghettification. That's right, you won't immediately turn into a noodle. The event horizon is not a physical barrier, but a point in space where gravity becomes so strong, not even light can escape. Now, here's where things get even weirder. If you were to look back towards the universe you've left behind, you'd see time itself speeding up. Stars would be born and die in seconds. Galaxies would spin like tops. This is due to gravitational time dilation, a mind-bending consequence of Einstein's theory of general relativity. As you get closer to the black hole's heart, the singularity, gravity's pull becomes stronger and stronger. Eventually, it becomes so intense that it stretches you into a long, thin line, a process known as spaghettification. Yes, the noodle fate awaits us after all. But what happens inside the black hole, you ask? Well, we're not quite sure. The laws of physics as we know them break down beyond this point. Some theories suggest a portal to another universe, while others propose a crushing end. It's a journey shrouded in mystery, a cosmic enigma waiting to be unveiled. Surviving a trip to a black hole might be impossible, but hey, we can always dream. Maybe one day, our understanding of these dark wonders will illuminate the path for a safe journey. Until then, let's keep exploring the fascinating unknowns of our universe. Fancy a trip to the past or future? Let's talk time travel. Now, we're not offering any vacation packages just yet, but it's worth exploring the theoretical possibilities, don't you think? Time travel has been a staple of science fiction for ages. But could it be more than just an imaginative plot device? Well, in the realm of black holes, wormholes, and the multiverse, the idea might not be as far-fetched as it initially seems. Take black holes, for instance. These mysterious cosmic entities have such immense gravitational pull that they warp the fabric of space-time around them. Some theories suggest that this could potentially create a sort of shortcut through time. It's a bit like folding a piece of paper in half and poking a hole through it. You bypass all the space in between. But of course, the whole not getting spaghettified part is still a bit of a hurdle. Then there are wormholes. These theoretical tunnels through space-time could, hypothetically, serve as bridges to different points in our universe, or even to other universes entirely. Imagine being able to hop from one end of the cosmos to the other in a blink of an eye, or dropping in on a parallel universe for tea. It's a tantalizing thought, isn't it? Now let's dive into the multiverse. If we entertain the idea that our universe is but one of an infinite number, each with its own unique set of physical laws, then the concept of time could vary drastically from one universe to another. In some, time might flow backwards, or sideways, or in a loop. Who's to say we couldn't find a way to navigate these different timelines? But wait, you might say, this all sounds pretty speculative. And you'd be right. These theories are still very much in the realm of the theoretical. But remember, it wasn't so long ago that the idea of humans flying was considered an impossible dream. Yet here we are, booking flights on our smartphones. Time travel might still belong to the realm of science fiction, but who knows what the future holds. Scene script. Ever wished for a shortcut through space and time? Welcome to the world of wormholes. Imagine if you could step into a portal in your living room and instantly emerge on the other side of the universe. Sounds like the stuff of science fiction, doesn't it? But in the realm of theoretical physics, this isn't just an idea plucked from a sci-fi novel. It's a serious proposal known as a wormhole. Wormholes are essentially hypothetical bridges through the fabric of space-time, predicted by the theory of general relativity. They're a bit like cosmic shortcuts that could link different parts of our universe, or even more intriguingly, different universes entirely. But before you start planning your weekend getaway to another galaxy, it's important to remember that wormholes are purely theoretical at this point. While the mathematics of Einstein's theory allows for their existence, we've yet to find any empirical evidence to prove that they're real. Moreover, even if they do exist, they might not be as useful for space travel as we'd like. You see, wormholes are incredibly unstable. They'd likely collapse as soon as anything tried to pass through, unless some form of exotic matter with negative energy could be used to prop them open. And currently, the existence of such matter is still up for debate. It's also worth noting that wormholes could be infinitesimally small, around the size of a quantum particle. So unless we figure out a way to enlarge them and keep them stable, they won't be of much use for intergalactic travel. But who knows? As we continue to push the boundaries of our understanding, we might just uncover ways to harness these cosmic shortcuts. After all, the universe is a place of infinite possibilities, full of mysteries waiting to be unraveled. So, could wormholes be our ticket to other universes? Only time will tell. Ready to dive into the weird and wonderful world of quantum physics? Let's plunge right in. Quantum entanglement, a phenomenon that left even Einstein scratching his head, is one of the most fascinating aspects of quantum physics. It's like the universe's version of a ghost story, except this one is real, and it's happening every nanosecond, everywhere. Imagine you have two particles. Let's name them Alice and Bob, because why not? These two particles are entangled. This means that the state of Alice is directly related to the state of Bob, no matter how far apart they are. Change Alice's spin, and Bob's spin will change instantly. It's like they're two sides of the same coin, always in sync, always connected. This happens faster than the speed of light, which contradicts the limits set by Einstein's theory of relativity. Hence, Einstein famously called it spooky action at a distance. But here's the thing. This isn't just a theoretical concept. It's been proven in labs. Experiments have shown that entangled particles behave exactly as quantum physics predicts. This isn't just spooky, it's downright mind-boggling. Now, let's zoom out a bit. Quantum entanglement isn't just about two particles in a lab. It could be happening all around us, all the time. It's possible that everything in the universe is interconnected in ways we can't even begin to comprehend. It could explain how information is transferred across vast distances in the cosmos, and it could even have implications for the concept of parallel universes. So why does this matter? Well, aside from completely shattering our understanding of how the universe works, quantum entanglement could be the key to future technologies. Quantum computers, secure communication systems, even teleportation, all these could be made possible by this spooky action. Quantum entanglement might seem spooky, but it's just another example of how wonderfully weird our universe is. So the next time you look up at the stars, remember, there's a whole lot of spooky action going on out there. Let's take a trip down memory lane and see how our understanding of the universe has evolved. Our journey starts with the Big Bang Theory. a colossal cosmic explosion that birthed our known universe around 13.8 billion years ago. This theory gave us a solid foundation to stand on, but as we learned more, we realized the universe was a lot more expansive and complex than we first thought. Enter the concept of the multiverse, a game changer in cosmology. The multiverse theory suggests that our universe might just be one of many, a single bubble floating in an infinite cosmic sea of other universes. Each of these universes could have their own laws of physics, their own galaxies, stars, and planets. It's a mind-boggling idea that has pushed the boundaries of our understanding, and we're still grappling with its implications today. The universe is a cosmic puzzle, and we're just beginning to piece it together. Ever heard of dark matter and dark energy? No, they're not the latest superhero duo. They're the invisible forces shaping our universe. Dark matter, an unseen substance, is thought to make up about 25% of the universe. It doesn't interact with light or other forms of electromagnetic radiation, making it virtually undetectable. Yet, its gravitational pull helps keep galaxies from flying apart. Now let's talk about dark energy. This mysterious force is causing the universe to expand at an accelerating rate. Think of it as the universe's personal space getter. It's estimated to account for nearly 70% of the universe's total mass energy content. Intriguingly, these elusive entities might be intertwined with other cosmic phenomena like black holes and the complex structure of the multiverse. So, while we may not see them, their influence is all around us, silently shaping the cosmos. The universe is full of mysteries, and dark matter and dark energy are two of the biggest. The multiverse theory isn't just about science. It also raises some profound philosophical questions. Think about it. If there are an infinite number of realities out there, each with a version of you making different decisions, it makes you wonder, doesn't it? What does it mean for free will? Are we just a product of one random universe among countless others? And then there's the question of identity. If there's another you out there, are they really you? Or are they just a cosmic doppelganger living in a universe where you took that job, or didn't miss that flight, or said yes instead of no? This theory also nudges us to rethink reality. Is our universe the real one? Or is it just one among many, equally real, equally valid realities? The multiverse theory challenges our understanding of reality and our place in it. It's food for thought, isn't it?